Welcome back. We're going to keep the automotive theme going with our next presentation from Mati and Todd from our longtime customer, Ford Motor Company. They're here talking today about optimizing Tanzu Application Service. Welcome, Mati and Todd. Take it away.
All right. Today, we are going to talk about optimizing Tanzu Application Service usage at Ford Motor Company. Next. All right, so a quick intro. My name's Todd Hall. I am part of our customer success and consulting team inside of Platform Enablement. And I'm joined by Mathi, who is a consulting architect out of our enterprise architecture organization in the Dev Enablement team. So the two of us are going to go through this presentation together. Next. And from an agenda perspective here, I'll be taking us through the first three sections here, covering our Ford journey with first Pivotal and now VMware, specifically around our use of what was PCF and now is TAS. I'm going to share with you a little bit about a product we created called the Cloud App Optimizer. We're going to share our experience using what we term application accelerators, also the enablement and automation of those items here at Ford. And then wrapping things up, Mathi is going to take us through a little bit more about additional success stories that came out of the use of our application accelerators. And he'll wrap it up with a little bit of roadmap discussion. What's next for us here at Ford and our use of TAS. So next. Yeah, this first section, like I said, and the intro by Estella was shared. We're longtime customers here at Ford. And so I thought it'd be valuable to kind of lay the foundation of, how we came to be customers of and users of the Tanzu Application Service product. So let's go next slide. And before we really talk about the technology stuff, first, there might be a few people out there that haven't heard of Ford Motor Company. I know we're one of the most recognized brands in the world, but in case you hadn't heard, we were founded in 1903 by Henry Ford, and we're headquartered in Dearborn, Michigan. And the last full year of data we have from 2020, we produced 4.187 million vehicles, and those vehicles are under the Ford and Lincoln brand names. So as you can see, the awesome products we have there on the right are some of our most popular Ford and Lincoln products. And something that sets the scale for you, we're a global company. We have folks in virtually every corner of the globe, and that comprises 186,000 employees. So that's my way of saying we're big, and we build lots of cool stuff, a lot of cool products. Next slide. So let's switch gears and talk about history and scale of Ford's use of Tanzu Application Service. And just to give a forewarning, you might hear me slip and say PCF. You might sometimes hear me call it TAS. And the reason for that is we've been customers of the product that, as most of you know, is based on Cloud Foundry. We've been users of that product since about 2016. So the PCF name still is widely used at Ford and probably more widely used than TAS. So you may hear me slip up with that. So consider them used interchangeably, but we've run TAS on-premise and in public cloud. And just to clarify things, the TAS product I'm referring to is, I believe, VMware officially refers to as TAS for VMs. So it is using Bosch. It's running on virtual machines, not on any Kubernetes clusters or pods. So with that, like I said, we run it on premise and we run it in public cloud. And specifically on premise, we started our journey in a couple old data centers that have now been decommissioned. And during this journey, we built 2 brand new data centers. So TAS has migrated across those data centers for us here at Ford. And from a public perspective, we're running in what I'll say the big three cloud providers. So we have foundations running in Azure, as well as AWS and now Google Cloud. So lots of foundations. So that the count is at current point 18 foundations, and they're hosted in North America, China, and India. So and that, like I said, is an intermix of on-prem as well as public cloud. Also, to give a little context around how big our footprint is with the product and how widely it's used here at Ford, we have over 35,000 application instances or AIs running across these foundations. So very big investment, very big footprint of apps running here at Ford Motor Company. Tanzu Application Service also, we considered our first or primary option for hosting of cloud native apps. And what I mean by that is we run things on all kinds of platforms, whether it's mainframe, Kubernetes, or virtual machines themselves. But when it comes to building brand new apps, we absolutely are committed to building cloud native apps here at Ford, microservice style architecture, very much focused on building API centric apps. And our primary host for those today is Tanzu Application Service. So let's go next slide. And to set a little more context, share a little bit about our technology stack. So we talked about platforms, where we run stuff, but what is that stuff that we're actually running? This slide, I'm going to take you through some of our technology decisions. But overall, overarching, we do have the freedom here at Ford to use whatever technology we want. So teams can use whatever programming language or frameworks that they feel are a fit for them. But we have certain guardrails in place that help, I would say, steer people in certain directions so that we get that economy of scale and that understanding and supportability with common technologies. So we absolutely have been a Java shop for many, many years. And what we see today in Tanzu Application Services, the use of Spring and Liberty. Our Liberty footprint really is a function of the fact that we ran a lot of WebSphere previous to cloud days here. So a lot of our WebSphere applications were able to be migrated, ported, lifted and shifted, if you will, to Tanzu Application Service by leveraging the Liberty build pack in the platform. So we do have a lot of that legacy stuff still around, but most of our new stuff has been Java and Spring. And front-end technologies as well are covered JavaScript. You'll see a lot of Angular and React at Ford. And from a server-side perspective, we have some Node.js that gets used. And Python and static HTML, et cetera. Definitely, you'll find those on our platforms. But our quote-unquote standard technology stack, and the numbers bear it out in our platforms, over 80% of our apps are going to be comprised of either the Java Spring Boot ecosystem, again, API microservice style apps, or the front-end presentation layer technology, JavaScript Angular framework in particular, for those microservices that need a user interface. So that standard technology, 80% is a good, definitely the majority of apps with this technology stack. So, and on top of the discussion around technology stacks, I just wanted to share that and it really goes with the concept of guardrails, right? Is that we have a couple organizations that are active in the community. I had mentioned Mathi and I are both from enablement organizations here at Ford, helping set direction, helping teams pick technology, help them understand how to use the technology. We're there to help teams understand how to use our platforms. And we have an awesome infrastructure organization that internally we refer to as ITO. Our ITO organization they support our infrastructure. They make it available, and we partner very closely with them to ensure that what we deem as our standard technologies all work very nicely and cohesively in our platforms. So, yeah, our team provides consulting, developer guides, code in the form of reusable libraries, support. They reach out to us. We do consulting engagements. And of course, we also, everyone's doing DevOps, DevSecOps, really the power of automation, and we provide guidance in that area as well. So that's it on technology stacks. So let's go next. So next up, we're going to talk about, so I've set the kind of the scene here, and Ford's this big place. We're using various platforms. We like our Tanzu Application Service platform. We run lots of technologies, but we tend to focus or standardize on the Java Spring Stack. And all of that is setting the groundwork for what we call our Cloud App Optimizer product. So let's drill in and learn about what the Cloud App Optimizer is. So let's go next. So what is it, and why do we have such a tool? So let's start with the what. The Cloud App Optimizer is a web-based tool that allows us or allows our teams to maintain a schedule for application instances. So in the previous slide I shared with you, we got 35,000 application instances. I mean, that's a lot. We're building a lot of product. The cloud, our shift to cloud has really made it easy for teams to build apps and deploy apps, but that's also how you get to 35,000 app instances running in your platforms. So Ford internally, just like public cloud providers, we handle our hosting on a consumption basis when it comes to billing. So when our teams run products, they are billed for the usage of infrastructure, and we do it by consumption, just like I said, the cloud providers do. So this poses a little problem, right? The more we run out there, it can drive costs up. Do we really need to be running all that stuff 24/7? So along comes this idea around building a product or tool that will help us control or optimize our usage of the platform. So specifically for the use case where teams happen to be co-located in a geographic region, a time zone, it makes a lot of sense to allow these teams to start and stop their applications on a schedule. In particular, I want to be able to stop my app on nights and weekends. Our people don't work 24/7. So let's enable them to effectively optimize the use of resources like infrastructure. So obvious candidates for this type of scheduling of resources are your development environments, your QA or QC, whatever you happen to call it at your place of work. Experiments, POCs, these are all great examples of applications that don't need to be running 24/7. So most of the time people forget that they have this stuff running, or think that, oh, it's someone else's problem, or I don't worry about the budget because I develop code. But we all have to worry about budgets. So along comes this concept of our Cloud App Optimizer. So I'll shift gears and we'll take a look. We'll drill through the screenshot here. I'm brave, but I was not brave enough to do a live demo. You know how live demos go. So you get a screenshot today, but I think the screenshot does a good job of really showing what does a schedule look like. What's the experience for us here at Ford in creating a schedule for my particular app, or and as you'll see here, for multiple apps. So what you're looking at is a screenshot of our Create Runtime Schedule screen in the app. And the first thing a customer is going to be faced with is picking an app or applications that warrant being shut down on some sort of schedule. So for folks that are familiar with Cloud Foundry or Tanzu Application Service, you're familiar with the concept of foundations, orgs, and spaces. So what you see on this screen is we selected, I had mentioned we have 18 foundations. So that first drop down for foundation, I can pick a foundation that I have access to. So a key point here is on this screen, a user is authenticated and presented with only foundations, orgs, and spaces that they have access to. So I have access to this foundation called EDC2, pre-prod. And then the organization dropdown would populate with the orgs within that foundation that I have access to. I selected a specific organization. And then I go on to space and I pick a specific space in that organization. And that leads me to the important part, which is the application dropdown, which I selected 2 apps. So that dropdown would present me with all the applications that are running within that space. So let's take a look at the applications. And this is important when we talk about consumption-based billing. Is most of the time consumption-based billing is done on a memory consumption perspective. So what you see here is 2 apps. I have one that represents a Angular user interface app, and the other one's a Java Spring Boot app. The first app there is using 0.12 gigabytes of memory. So that's obviously the user interface. It's a static build pack, just hosting JavaScript. And you'll see it also denotes that there's 2 application instances. So it's scaled out to 2 instances. And in harmony with that front end is a back end, that Spring Boot app. Those app instances, there's 2 of them, and they're of size 1 gigabyte. So right here, I've identified 4 application instances that can be shut down and save 2.24, if my math is correct, 2.24 gigabytes of consumption. So after I pick the apps that I want to run on this schedule, I go into the actual scheduling point. So I pick what days I want to run. So I'm going to go with a very simple, classic, we want this to run Monday through Friday type of schedule. So the days I selected were indeed Monday through Friday. The time zone, we here in Michigan are in the New York or Eastern time zone. And my team in this instance is in, the first person's in by 7, let's say, and the last one leaving for the day, or I should say signing out for the day, is 6 p.m. So based on this schedule and the applications that I picked, the user interface is going to share with me that this schedule results in 226 hours of downtime. And I have 2 apps represented there. It calculates the percentage of downtime. So believe it or not, we think we work endless hours, but a typical work week, we get 67% of free time. So my apps get 67% of downtime in this scenario. And we have the cost savings information blocked out. It was deemed sensitive, so we're not sharing that, but a customer of the app absolutely would get immediate feedback as to the cost savings they would get out of shutting apps down. And then let's move on to the bottom section. I can choose the reoccurring range that I want this to run. So in this example, I decided from September 1st to the end of the year, December 31st, I would like this schedule to be enabled. And that decision of this time range here results in a cost saved data to be displayed at the bottom for the range itself, and for it will extrapolate that and tell me that for a given year or a 365-day period, I could expect to save X amount of dollars. And again, that's our internal budget dollars that we'll talk a little bit about in a minute. And the last thing I want to point out on this slide is that our users at the top of the screen get a running total of, since this product went GA back in April of this year, what have we saved in terms of our budget dollars by shutting apps down, and how many total downtime hours have we enjoyed out of this? So that's it for kind of the high level of what the optimizer is and what it does. So let's go next page. Here, I'll quickly talk about metrics, and on this metrics sheet, you'll see that a lot of the sensitive dollar sign type data has been blocked out. But I think you'll get the spirit of what we realized by implementing the tool. Like I said, April of this year, we launched and saw quite a bit of growth. We did a little bit of advertising internally, letting people know about this. We worked with our infrastructure teams. I identified some of our larger consumers of resources in our platforms, just to let them know, hey, here's this tool. It may save you some budget dollars, which I'll get to in a second here. But our general use case, our standard vanilla use cases, the typical team can save about 50%. And we derive that by just saying a lot of teams have a dev environment, they have a QA environment, they have a prod environment. So if you're able to shut down dev and QA 67% of the time and run that prod 24/7, like we'd like to see, that math gets pretty close to 50% of your overall consumption hours. So, and let's talk about those consumption hours and the consumption costs. So internal here at Ford, we have this concept of what we call blue dollars and green dollars. So blue dollars, it's blue because the good old Ford blue oval there. We like our color blue. So blue dollars refer to the budget, internal Ford budget dollars that float around. So initially, this product is saving teams their internal blue dollars. But and that's useful for the teams. They get finite budget dollars to spend on infrastructure. And if they can more effectively use infrastructure, they can use those dollars elsewhere for other costs related to their project. So it does help out the team, but obviously we'd like to save real green dollars. And when we say green dollars, we mean dollars exiting the company, checks that are being written to various vendors for hosting infrastructure. So as Ford moves to more public cloud, and we are seeing a shift where we're seeing more and more stuff run in public cloud, tools like this provide an opportunity to reduce our real green dollars, and everyone likes to do that. So that is the selling point of the tool. And the last bullet here, I'm just highlighting that, I talked about our typical 50% consumption cost savings, typical team, but we have some outliers that are very complex applications, and they might be running 10 plus microservices. And because of their sophisticated development lifecycle, they may run numerous environments before they hit production. Dev, QA, education, pre-prod, load and performance. I mean, world of cloud, the world of using Tanzu Application Service, each team can set up their spaces to fit the needs of their development processes. Gives a lot of flexibility. But again, that flexibility causes lots of AIs to be created. So some of our complex programs have been able to save substantially on their billable consumption hours of their product. Like I said, we were able to identify some of the heavy users, reach out to them, and assist them with onboarding to the tool. So we expect good things out of this, and we've gotten great feedback from those teams that, again, didn't need to run all of those things 24/7. So I think the beauty of this is the ultimate agility it gives our teams. The cloud is given agility in people standing stuff up, using orgs and spaces as they see fit. But we have no way of knowing what's the right thing to turn on and off for people. So we hand over the power to the teams, and they are able to customize it to meet their precise needs that they know best. And that's really at the heart of our product-driven organization model here at Ford, is that we try to give the teams the power and the capabilities to do what's right for them. So, and lastly, I'll just point out, I mentioned the graphic here. We have a Grafana dashboard. Probably people recognize Grafana. We're monitoring the use of the tool. We can see steady growth. We can see the consumption hours improving as we go. And we can see the number of events firing since we inception in April, 158,000 start or stop events, 1,232 apps. So it's we're able to see that we are continuing to grow, and people are happy with the product. So let's go next slide. So now I'm going to take a step back and talk about innovation in APIs, and how that relates to the Cloud App Optimizer product is the fact that this product was created during some time we call power up time here at Ford. So Ford reserves this power up time for all IT employees to really, put aside the day job and focus on learning and innovation. So like I said, the Cloud App Optimizer absolutely started by leveraging this time. And in fact, it was me that took my time in this power up to start taking on this challenge. I had an idea. I'd met with a lot of teams as a consultant here internally, realized that there was lots of people maybe overwhelmed by the amount of hours they were consuming in the platforms, trying to build their own scripts to turn things off. So that sparked an idea to see how could we build something that would simplify that for our teams. So leveraging power up time and the many tools and processes we have at Ford, specifically application accelerators, automation, and of course the power of the API. Those were all really key enablers that allowed me to work on this and get it at least to a point where it could be demonstrated to management, stakeholders, and see if it was worthwhile taking this from concept and POC to a real product. So let's go next slide. So that innovation and thinking led to not just the Cloud App Optimizer product, which, like I said, was really well received by our infrastructure teams and product teams. It also sparked the idea of, well, we have other platforms that we run apps. I shared with you that while Tanzu Application Service is primary, we do run stuff in Kubernetes like everyone else in the world, and we run on VMs like everyone else does. So it just made sense. Why don't we also explore how we could do a similar product for those platforms and attack the blue and green dollar savings as we, again, move to public cloud offerings. So the tools or apps for both of those platforms are under development, and it's really cool that a lot of the code could be reused from the initial app, and we're making great progress toward getting those released as well. So let's go next slide. All right, so this is my last section to cover, and it's on application accelerators. You heard me use that term a few times. It was key to getting a product like the Cloud Optimizer out there. And I like the word optimizer. It's we're playing on that term in this presentation title because I happen to think that our application accelerators also optimize our ability to use Tanzu Application Service and optimize our ability to get product and cool ideas out the door quickly. So that's what we're going to cover in this next section. So next slide, please. All right, so the first, I would say it's an app and a tool or product that we call internally DevCentral Station, and the name derived from a train station that we are refurbishing here in the Metro Detroit area, where we intend to house a lot of our technical professionals in the near future. So that term came for the name of this product. And what is this product? It's a development portal for our software engineers who need to create a new product, or for software engineers or anyone else that is interested in innovation or learning and just want to explore technology. So this particular portal it houses several templates supporting different languages. So very much like start.spring.io, a Ford developer can go here, click on a tile, and get started with the beginning of building a product. And each one of these templates provide a scaffolding for that initial product that you want to build. We set up the structure or scaffolding of like a building, and let the developer come in and finish it off with real business functionality. So in addition to the various language and framework type templates, we also have a tile there for our API hub. And that is a workflow for onboarding people to our API catalog. So Ford very much has invested and embraced the API model. Everything we build has APIs involved, and the API hub helps people either find and consume APIs or publish new product as APIs into our API catalog. So that is a key part of DevCentral Station as well. Everyone's talking DevSecOps and CI/CD automation with good reason. They're great ways to simplify and streamline delivery of product. And we help that along. Many of our templates include pipelines so that our developers can, out of the gate, have automation in place for delivering product for the specific language or framework that they choose here. And just as I'll say a success story, using this tool, in particular, the Spring Boot Java template, you can create a new project, have it added to a GitHub in the form of a new repo in Ford's enterprise GitHub repository. You can have it automatically onboarded to Jenkins, where Jenkins will build and deploy that new product, and have it automatically deploy to a Tanzu application trial account. And so any user in the company can do all of that. And after a few clicks and the project is created, it goes from that to within 4 minutes, the pipeline will deliver your brand new product to a Tanzu application service. It is what we call commit 0 or commit 1. And it provides, like I said, the scaffolding and a very simple, perhaps hello world experience. But the kind of the phrase I share with people is that we're going to give you that first commit in GitHub, and we'll get something very simple delivered. You and the product team can go in there, add business functionality, and commit to and beyond is all up to the product team. And you no longer have to fuss and toil with setting up pipelines and getting onboarded to infrastructure. We rely on the power of APIs behind this to really empower our developers to get that basic stuff laid down easily. So that's DevCentral Station. Very, very successfully, very popular, and just enormous usage at Ford, in the tune of perhaps like 7,000 project generations a month. Very, very widely used. That leads us to the next really powerful enabler and accelerator, and that's our Ford Cloud Portal product. In fact, we talked about our relationship with Pivotal and now VMware. The folks from Pivotal at the time that were on staff with us here on board at Ford with us and partnering with us worked shoulder to shoulder with us in building the initial concept of the Ford Cloud Portal, and specifically the tile that you see in the upper left, which is enabling the automated provisioning of Tanzu Application Service orgs and spaces. So any user inside of Ford can go here, and it's the one-stop shop for requesting good old PCF/Tanzu Application Service or databases, containers. My product, I can go here and request what we call a vanity URL, which is a myapp.ford.com type domain name. I can get subscriptions to Google Cloud or Azure. I can get Kubernetes space to host Tecton pipelines. I can get SQL servers or Postgres SQL databases. And like I said, very much empowering the innovation and power up mindset you can get 120-day trials. So anyone can use this for learning exercises or innovation ideas. So this has been, again, another just wildly successful product that really has just cut down on the toil for the developer. What used to, and I'm dating myself, and I'll say back in the old days, requesting infrastructure before the cloud and before automation was tickets, billing meetings, and lots of process that ended up in months to get your hands on infrastructure. And we have that now where you're literally clicks away from getting access to infrastructure in literal seconds. It's just remarkable that we've empowered our folks to be this fast and delivering at market value. So that's it for our accelerators. Next up, Mathi's going to share some other success stories that we've had with our accelerators.
Thank you, Todd. So Todd had mentioned a couple of core foundational things that we have built. One was a DevCentral Station, the other was a Ford Cloud Portal. So most of the software engineers, the main vision is software engineers need to develop products, not worry about the tech stack. How do we integrate our security? How do we integrate our CI/CD pipelines? So all those things are being baked into those foundational services that are offered as accelerators. And then how do we build real business value for the customers? So a couple of examples, real examples, using these accelerators, how we achieved last year. So the first one is a COVID-19, right? Last year in March of 2020, so when the COVID-19 was spreading across North America and across globe, Ford senior leadership made a decision to shut down most of those assembly plants across the globe. And now they wanted to resume the manufacturing again by May 2nd week. But we have a very large global base of suppliers now across the globe, 3,900 plus suppliers. They also got affected by the COVID-19 situation. So how do we understand what is the risk? The suppliers have to resume production and they have to supply the parts to Ford so that Ford can resume their assembly plants and start assembling the vehicle and deliver it to the dealers. So the purchasing business leadership, they reached out to us on April 5th, and they said, no, we need to do it. So normally, till 2020, before that, they used to handle all this thing through Excel documents. So they'll send an Excel to their suppliers. So everything was tracked through Excel, which was very inefficient. And now with this crisis, they wanted something to be stood up quickly so that they can, the leadership, senior leadership can have a visibility every day, what is happening with those suppliers, how they are remediating their risk, and are they ready? So we stood up again, going back to DevCentral Station, what Todd pointed out, we have a Spring Boot Java tile that has all the technical stack. It is integrated with your CI/CD pipeline, your FASA for your open source software that you use, the licenses, the vulnerability part, Sonar Cube, check marks, everything integrated into that, and also it does a blue-green deployment. So the whole tile, there are two, we used two of them. One is the EcoBoost, what Todd calls as EcoBoost, Spring Boot Java tile. The other one is a Ford responsive framework, which is an Angular tile, which is used for progressive web application. So now you develop that application, it is not device agnostic, it can be rendered on any device. Because one of the requirements was, some of these suppliers, they wanted to be mobile enabled. So we took those two tiles. Within 10 days, using this DevCentral Station and Ford Cloud Portal and getting the requirements from the business, we are able to implement the business logic of tracking all this surveys risk and then providing them a dashboard. So really in 10 days, we are able to productionize it and share it with a global audience of 3,900 suppliers. It's also the suppliers. The authentication part is normally for Ford employees, we use ADFers, whereas for third-party suppliers, we use Covisint and another third-party tool for getting access to them into the Ford network. So all of these things could be achieved in 10 days. It's one of those, it went up to the leadership at the top CEO level, not the visibility CEO and CEO level. So this is one of the use cases. The second one is on we have embarked on a very big, large program, integrated ERP program, bringing in SAP S/4HANA. And initially, we are looking at moving all the business processes in the finance and the purchasing side of the organization. So as part of this, there will be sunsetting around 200 applications. So and they integrate with the more than 150 source systems which feed data into SAP. So there's a very complex microservices API architecture that has been defined, and they want to have these, whatever the transactions that failed, they want to reprocess it, because they need to go, these finance and purchasing applications are SOX compliant applications. They need to have auditability and traceability. So they came to us. We use the same, again, we use the EcoBoost Java tile and the FRF Ford Responsive Framework Angular tile. We built this whole API microservice centric architecture and built that the product. And it is really all these 150 plus applications are interfaces that are using this. Now, if they had to do this error and reprocessing logic, it would have taken a long time. So we launched this SAP S/4HANA for Canada this May of 2021, and next May 2022 we are going to launch for North America, especially for US. And this framework was possible because we had all these accelerators that are already available. If we have the CI/CD pipeline, everything is there. So just we need to build the business logic. So using these styles repeatedly again and again, we were able to create products quicker and deliver value. Even the DevCentral Station that we are talking about, it is built on that. There's a DevOps command center, which is again for the software engineers, to increase the productivity of the software engineers, especially for them to get onboarded to different tools. They have to raise different requests with the different systems. So which is very, kind of inefficient when a software engineer is onboarded. It at least takes 2 weeks for that person to be productive. So to reduce and compress that, we are creating that DevOps command center, wherein the product owner or the product manager can go and he has a 5 or 10 software engineers. For each one of them, what is that? What are the tools that they need? They can select and then get it automated. Provisioning is done. So even that tool is built on top of these two accelerators. So we have software developer ecosystem, wherein the software, when as new software comes into Ford ecosystem, they can understand what are the product types that are available, what are the patterns, what are the tools that are available. So a one-stop place where they can understand, okay, now if it is a Java, if I'm going to build my product on a Java stack, these are the tools that are available. This is the place I need to go. So everything consolidated for them, consolidated view, a 360-degree view. For the software engineer, so that he doesn't have to scratch his head finding things. And then the last one, the hybrid workplace scheduler, is another product that was built on top of these accelerators. Today with the remote working, slowly starting 2022 January, most of the IT of people will be going into work, but it's going to be a hybrid model. So they have to schedule their workplace through an online tool. Even that online tool was built on these accelerators. So coming now to the roadmap. So Ford is always looking at the futuristic things, correct? So we are in a connected vehicle space. Battery electric vehicles is our future. So a lot of these things, IT has to support them. So over the air update is one of those critical spaces, battery electric vehicles, autonomous vehicles. So for all of them, what are those other tech stack that we need to look at? So first thing is DevSecOps, because we are in a connected vehicle space. Now, security is very, very critical. Cyber security is very critical. So as part of building these software products, we already, provide a opinionated CI/CD pipeline in those tiles in DevCentral Station for those tech stacks. that includes FASA. FASA is primarily used for checking the any open source software that I'm using for developing a product. So does it adhere to Ford's uh, license agreements? Does it adhere to the security? It also checks the security vulnerabilities, CVEs against NVD database, and it tells us does the open source software have any security vulnerabilities and things like that. So again, check marks for our static security. Black duck is for binary, and then 42 crunch is mainly a tool that is used to check the open API specifications for all the REST APIs. So we are big into API strategy as part of this connected vehicle programs and battery electric vehicle programs. Everything need to talk through APIs, correct? Even a remote start, stop, Amazon AWS delivering goods into a car's trunk, everything driven through APIs. The other thing we are looking at is, as part of this API strategy, we are looking at GraphQL, gRPC, async APIs. Primarily, our focus is on REST. There are spaces where GraphQL is very helpful. So we all know Facebook started this, and then they open sourced it a couple of years back. And especially in the experience layer, where the devices are small, where the network latency is very high, and the bandwidth is small. Really aggregating data for that specific device. GraphQL is very useful, and we have already implemented in the AV space and the e-commerce space using GraphQL. So gRPC is again, we are looking at where we need persistent connections between the vehicle and the transportation mobility cloud. We use that. Async APIs, we are using it in IIoT space. So these are the areas we are trying to standardize and provide the way we provide for Java EcoBoot, the Java Spring Boot. We wanted to we are going to provide tiles for people who want to develop APIs using these API styles. Again, as Todd pointed out earlier, we have established an enterprise API catalog, and the API marketplace is it's a work in progress. The API catalog is primarily to identify what are those APIs are considered as an IT asset now, and there is a lot of importance from the leadership team to make sure that we are not duplicating effort at the same time. There's a common language when people are talking about an element attribute, so everything is standardized and we all adhere to the open API specification 2.0 or 3.0, correct? So really the API catalog, now it has been mandated that anybody who creates an API, the API needs to go into the API catalog, and so that people can discover and identify whether or not whatever they need is already available. If not, they will go and build a new API. So, and then the fourth one we are focusing on the serverless architecture, serverless event-driven architecture. As Todd pointed out, we have footprint in on-prem, we have footprint in GCP, Azure, AWS. So as we the connected vehicle space, there's a lot of this event-driven architecture is required. So one of the programs currently we are working on is the vehicle collision assistance program, where when a person gets involved in an accident, the immediate events get triggered. A 911 call, calling a service center, calling a towing center, or calling other insurance companies. Everything is an event, and serverless is becoming very critical. So we are looking at today, Azure function as a service. On-prem, we are looking at Knative, on-prem and GCP. We are also looking at Cloud Function and Cloud Run. So some of this as part of this enablement process, as Todd pointed out, about the platform and the dev enablement teams, we look at and guide the teams, a kind of a decision tree. We tell them, guys, when do we use a Cloud Function versus a Cloud Run versus Knative. So really, that is another area we are focusing on. The last point I talked about is the application tools, infrastructure access. Really, the DevOps Command Center, that tool is going to not only help the software engineers get access to the tools that they need for their product development, also some of the applications, the access to the applications and also the infrastructure. So it's going to be a one-stop shop where the product manager or the product owner can go in there, and then for a software engineer, what are the applications you need access to deliver the product, what are the tools, and what is the infrastructure, whether it is a PCF TAS infrastructure, or is it a container OpenShift, Red Hat OpenShift container infrastructure, whether it is in public cloud or on-prem, everything will be automated. So that's what we are looking at. So last, as here we have a very large, emerging technologies and innovation center in Palo Alto, and there are exciting opportunities, for people who are interested. Really, we are into the battery electric vehicle space, autonomous vehicle space. There's a huge investment at $27 billion in the next 3 years on the battery electric vehicles. $7 billion has been allocated for autonomous vehicles. So people who are really, we are looking for very smart people, and there is a lot of challenging opportunities here. It's really going to be very exciting. So if you are interested, please go into careers.ford.com, and then you can apply for that. We love to see you there as part of our Ford family. Third, I'm done. I think we are good. So.
Wow, thanks, Todd and Mati. I loved seeing the agility that your team is benefiting from, and those cost savings were very impressive. You're really empowering your teams to do great work, and I especially love that last slide at the end. Ford is hiring in their technology teams. Very cool. You can all jump over to Slack and talk with Todd and Mati more about their presentation at Ford. If you go over to the right-hand side, there should be a live link there to their Slack channel, and you can continue a Q&A over there. So thanks so much, and we'll have a brief break before our last session of the day.